Army.
Yep.
Sorry, guys. I'm just trying to get my headset microphone fixed here. Give me just a second.
Uh,
Yep, I am the one teaching today. Most of it, at least. Garrett may be joining us later. So, but anyway, how's everybody doing tonight?
Good.
Everybody just anxious for another fun-filled, action-packed day of dispatch learning tonight,
yeah.
otherwise known as Week 6, Day 1.
Yay.
Uh,
What's that?
I said we made it, you guys.
Don't speak too soon.
We're halfway there.
Yeah, we got this whole week here, and now you guys are doing great. So, yeah, you are almost through the online portion, which is great to almost be done with this because it's a lot better when you're in person in class. I can tell you that.
I feel like you can understand it better.
Yeah, for sure, absolutely. So it, yep, it has to grind through these 6 weeks of online, but hopefully you've been able to learn a lot of stuff and hopefully retained, some of it. So sounds like you guys got pretty much wrapped up with the weather stuff. So how does everybody feel about that section in particular?
Mm,
I feel like it's a lot.
That feels a lot harder than the other subjects we've learned, just in my own opinion.
Well, it contains a lot more stuff that's actually pertinent to the job, I guess is the best way to say. Stuff that you're going to use every single day. Um, so, yeah, so we do put a lot more emphasis on some of it, although some of the weather topics um, aren't necessarily all that important. There is a good chunk of it there, especially those METARs and those TAFs and figuring out the 1, 2, 3 rule, applying it, reading charts and, knowing the difference between the weather minimums, the landing minimums, the legal to go, a lot of different rules that we apply in there with the weather stuff. Yeah, it's honestly, I would say that weather by itself is probably at least 50% of your job, of your overall job is weather. So um, there's a lot of things that you guys will learn as dispatchers that you don't, a lot of things that we talk about, a lot of things that we learn that you don't necessarily put into practice on every single dispatch release. However, the weather and the METAR reading and the TAF reading, that's something that you have to do on every single flight that you dispatch. So whether it's good weather or bad weather, you still got to look at it. You still got to look at a TAF for every single flight that you will ever plan or dispatch. So yeah, so it's a big part of the job, and really we can't spend enough time on it probably overall, but you're going to still see it a lot more. Even though we're done with the subject itself, you're going to see a lot more practical application of using the weather and reading METARs and TAFs. So that part of it's obviously not over because we're going to start doing a lot of flight planning and stuff, and you're going to see the repetition.
What what weather charts do I need to be super familiar with? I've got the AirMetch charts and the SigMetch charts written down. Courtney, I was studying with Courtney this weekend, and she was saying something about like the charts that I need to have memorized, and I was just wondering if I could like jot those down on a list so I make sure to look over them.
Well, as far as the weather charts go, the big thing is you need to be able to look at like the charts that have like the fronts on them, like the warm fronts, cold fronts,
Oh, okay.
like the warm fronts, cold fronts, high pressures, low pressures area, basically a lot of those graphical charts. I mean, there's some that we use, there's some that we don't. But when you're technically, when you're looking at a weather chart, like if you're sitting and doing real dispatch, you're usually looking at a graphical display of the weather, in any given part of the country. You can, zoom in, zoom out, you can look at the whole country, whatever. But when you need to be able to look at those charts and identify and be able to say, because just I'll give you the example of like what you're probably going to see in your practical exam. He's going to have weather charts out, either, printed out, or he's going to have his computer open and he's going to be pointing to stuff. And he's going to say, what's this right here? And he might be pointing to a cold front or a warm front. And what does this mean over here? So there's going to be a lot of that, not a lot, I should say, but when he goes over weather, he's going to probably pull out a couple of different charts and ask you a few questions, on, well, what's this? And it's not going to be anything way in depth. It's just going to be the basics of the chart. Okay. It's just going to be, he's not going to ask.
Nothing I'm not familiar with.
Yeah, definitely
Okay.
not anything that he's, like I said, he's not going to go into the science of everything, but he will expect you to know the basics of being able to read those charts. Once again, the practical is really he just wants to see that you know the basic information in all of the main subjects regarding dispatch. He doesn't expect that you're going to be a weather professional. He doesn't expect that you're going to know the aircraft systems in and out, but the basics. You just need to understand really the basic principles of what makes that system work, whether it be the hydraulic system or the anti-ice system, or whether it be, the weather chart, or, reading weather. He'll probably have you read some METARs, read some TAFs. He'll probably have you read some winds aloft. Yeah, I mean, that's what you can expect. So that's what you need to become comfortable and familiar with. Other ones that we use a lot, other weather charts that we use a lot, like the TCF chart that Garrett showed you guys. The one that shows like the thunderstorm collaborative forecast. That one is one that we use a lot in dispatch, just showing where it has a 4-hour, 6-hour, and an 8-hour forecast of where thunderstorms are expected to be. Yeah, a lot of that stuff, we're still going to see a lot of that stuff though, because when we jump into the flight planning, you're going to be looking at everything again. We're going to be looking at a lot. We're still got a lot of weather to look at in every single flight plan that you guys will do when we jump into that. So you're going to be looking at those charts still a lot. You're going to be reading a lot of weather. You're going to be figuring out whether you need alternates, legal to go, all of that stuff. You're still going to be doing a lot of that. So just because that particular section is over now, don't, just know that, we're going to tie it all back in. So, as well as everything else we've learned too, FARs, systems, anything else that we've talked about, you'll see it how we kind of put it all back into practice. And the nice thing about the flight planning stage is that every time we do a flight plan, it's like we're taking all of the stuff that we've learned these first 6 weeks, and it's like we're reviewing all of it every single time we do a flight plan. And you're going to do like, probably 7 to 10 flight plans. So you're going to, see it all a lot again. So anyway, but regarding the weather and, the topics most recently discussed, does anybody have any questions? Anything that you want to talk about, go over again, review? I know that last Friday you guys kind of left off with, with some videos and things like that. Did everybody get around to being able to watch those?
Yeah. They were just mainly aircraft crash videos, right?
For the most part.
Yeah.
Or, relating weather. I mean,
Yeah, exactly. All weather related. But the big takeaway on any of those, though, is what that specific weather phenomenon has on an aircraft, right? Whether it be microburst, volcanic ash, or any other type of weather that you guys saw in there. A lot of those crashes were monumental crashes in the aviation industry with regards to the rules and the knowledge that came from them. Okay, so that's why we show them in this class. Like as an example, the Delta flight that crashed in Dallas Fort Worth. A lot of new information and rules regarding microbursts came out of that crash. A lot of stuff that you see today that you will talk about, that you'll see, meaning today, like in the dispatch world, not necessarily today in class, but when, once you get dispatching, a lot of these things that you see, a lot of the systems and the protections that we have in place now date back to these wrecks that, these crashes that you guys have seen now. And, like for instance, still talking about that Delta flight, a lot of like the microburst detection systems that are now installed on aircrafts, things like, unfortunately, the one thing that's kind of, you start kind of learning as you study aircraft accidents is that back in, well, even as recent, even into the 2000s, but the 80s, the 90s, and even anything before that, you have, it would literally take an aircraft accident in order to change stuff. There wasn't, the whole industry was, as a whole, was completely reactive. It would not change anything, even though they had a lot of data and a lot of warning and a lot of pressure to change certain things. They wouldn't do it until there was a major accident and loss of lives. Then they would change that. So there's a common theme that you kind of see as you start studying aviation accidents over the years. And, even going back to when, aviation was a brand new thing, go back to the 20s and 30s and 40s. It's like every single flight was a test flight in a way. And there was a lot of accidents and a lot of loss of life over the years. But the key thing that you start seeing is that slowly they would implement more and more, and they would change. Every accident would bring about something new, something new that would be implemented and imposed, and rules that would be changed. And if you look like at like a line graph of, like aviation over the years, going back into like the 20s, and like the amount of people that die each year due to aviation related accidents, you'll see that it's kind of like everyone has seen an exponential curve, right? On like a mathematical graph or something like that. It's an exponential curve, except it's going, the opposite direction, where you used to have this huge amount of crashes and deaths every single year in aviation, and it has slowly gone down to where we don't have hardly anything. So hardly any wrecks. I think the most recent wreck regarding a United States airliner with passengers was 2009. So we now have gone 9 years without a major, accident with, fatalities. Now, obviously, there's been accidents. The only accidents that have occurred with United States, based airlines have been, well, everyone has probably seen the National Airlines crash, that 747 in Afghanistan. Everybody has seen that one? And so that was obviously a cargo accident. And then UPS had a wreck actually in 2012 in Birmingham, Alabama. So, but once again, no passengers involved there as well. So they're not really kind of looked at in that same scope. But regarding passengers, but even the most recent crash that happened, the one in 2009, it was the Colgan flying on behalf of United Airlines. It was one of their regional carriers, Colgan, up in Buffalo, New York. There was even a lot of change that came from that particular accident as well. So there was major rule changes regarding the amount of hours that pilots needed in order to be an airline rated transport pilot. So I'm not sure how familiar any of you guys are specifically with that, but the requirements went from only needing 250 hours all the way up to 1,500 hours off of that one accident. Yeah. But yeah, I mean, that whole topic is kind of another thing for another day specifically. But the overall idea there is that every single accident that's occurred over the years has brought about change. Some of them more than others, but a lot of these ones that we showed you last week or wanted you guys to watch over the weekend had a lot to do with weather and the things you guys have been studying here the last 2 weeks. So, but another big element into all of these accidents is kind of a leeway into what we're going to start talking about today as well. Every single one of those had human factor elements, human error involved with all of these accidents. Even the last 3 or 4 weeks that I've been at the FAA Academy here in Oklahoma City, we've done a lot of studying of aircraft accidents. So I've kind of been engulfed with a lot of interesting history and facts and figures the last couple of weeks that I've been here. So it kind of actually will help this week in what we end up talking about. But before I want to even get into any of that, though, I kind of still want to just discuss weather and any questions you guys have, and even just do a review for a quiz that I guess will probably end up being tomorrow. So,
my question is, the whole weekend I've been trying to find, so I go on the FAA website where it has all the weather charts, and I somehow can't seem to find a bunch of those different, AirMet charts. I somehow can't find any of these charts. So where can I find them?
Okay, so where are you going when you get on there?
Okay, so I go to, let me just kind of backtrack to what I do. So I go to, well, I don't know what it's called specifically, so I go to Google and then I type in FAA weather, and then the site that pops up is aviationweather.gov.
Yep.
And so I go on that, and it displays METARs, tabs, air, SIGMETs and all. But I know that there's a page where it shows you like all the different types of weather charts, like in one page, and so I somehow can't seem to find that.
Okay, so I'm going to aviationweather.gov right now. Watching my screen here. Okay.
Okay, let me go back to your screen. Hold on. Okay.
So this is the main screen that you come to when you go to aviationweather.gov, right here.
Okay.
Okay, so from here, you can, I mean, first of all, you can see, you know, METARs, TAFs, PIREPs, SIGMETs. You can click on any of those there to look at any of them more in depth if you want to. As far as this particular map here goes, you can turn things on and off just down here. Just, you know, see these little, I turned on satellite. You can turn on visible fog. You can turn those back off and turn on radar. So you can actually turn a lot of stuff on and off just right on this screen right here.
Okay.
Okay, so that's one thing. And then it obviously gives you the legend of everything that's on here. So that's that stuff. As far as, you know, if you go to advisories, you can go into the SIGMETs, and it'll actually just, so right now there are no SIGMETs. Okay. This also has center weather advisories turned on, and there's none of those going on right now. You can come back in and turn on AirMets if you want, and it'll show you the AirMets right there.
A lot of turbulence.
Yeah. Now, did you guys discuss the big difference between an AirMet and a SIGMET? Does anybody want to chime in with what the big difference is between those?
Yeah. An AirMet is areas of icing, visibility, and turbulence, and
So is a
significant
SIGMET then.
hazard.
A SIGMET is all of those same things, but what's the difference between a SIGMET and an AirMet?
I thought SIGMETs were, I just have written down here, they were the significant hazardous weather.
Yeah, that's what I have.
I don't know. Yeah.
Okay, yeah, so it's all the same things as an AirMet. The big difference is the word severe. Okay, severe. So a SIGMET, and it doesn't matter whether it's an icing SIGMET or a dust SIGMET or a turbulent SIGMET or a low-level wind shear or a convective SIGMET, which is thunderstorms. If it's any of those, if it is a SIGMET, it means that that particular weather is in the category of severe. Okay, severe. So if I am told that there's a SIGMET for turbulence over Colorado, it means just simply by the fact that it's a SIGMET and not an AirMet means that the category of turbulence is severe. Same with icing, same with any of them. Now, AirMets, generally speaking, dispatchers, you know, dispatching airline size type airplanes, we really don't care too much about AirMets. Generally speaking, AirMets are meant more for light aircraft, not necessarily the large transport category heavy aircraft that we deal with. Now, it doesn't mean that we completely ignore AirMets, because there are a time and a place where we do need to know about them. But just as an example, as a dispatcher, I normally don't even have my AirMets turned on. Okay? So if I'm dispatching 50 flights, there has to be something specific with that flight that I'm dispatching to make me even want to look at the AirMets. Otherwise, I don't even have them turned on. So as a general rule, we don't care too much about AirMets because they don't really have much effect on the planes that we dispatch. Now, a SIGMET, on the other hand, does. Okay, a SIGMET has effect on all aircraft, and especially even the ones that we're dealing with. So my SIGMETs are turned on, but my AirMets are not. Just an example of what might be going on that I would actually want to look at an AirMet. Let's say that I have a plane that I'm dispatching from Denver to Portland. Okay. Let's say that one of the MELs on that plane is an MEL that says that we cannot fly into icing conditions. Okay, so now I need to figure out, can I send this plane from Denver to Portland without going through icing conditions? Now that's a situation where I would want to pull up my icing AirMets and take a look. Okay, just that's one example. But yeah, generally speaking, if I didn't have that MEL though, I wouldn't care. Okay, I wouldn't care about the icing AirMet because our aircraft that we are dispatching, they have anti-ice capabilities, so we don't really care too much about it. Turbulence pretty much exists on every flight, whether it be light turbulence, moderate turbulence, but generally speaking, you're not gonna completely avoid turbulence hardly ever. So, if we get a SIGMET for turbulence, that's significant enough to where we're going to want to route around it, usually, if we can. So a SIGMET, though, like I said, I always have SIGMETs turned on. So a SIGMET for turbulence would pop up. But otherwise, I don't really care. If it's just an AirMet for turbulence, then not really a big deal. You pretty much have those every day, everywhere you go, almost. So yeah, so hopefully that kind of gives you guys a little bit of an idea there. SIGMETs, we care a lot about. AirMets, we don't care too much about unless we have an MEL or something else that makes us need to go look at it to avoid it. Okay, because even that MEL, that like if we have an MEL for no icing, that means we have to avoid all icing, even if it's AirMet category. Which means it's not necessarily severe icing, but it's just light icing. It doesn't matter what kind of icing it is. We have to avoid it. We cannot fly through it. So that's when we care about, even just an AirMet for icing. So hopefully that sheds a little bit more light on those things. But going back through here, so yeah.
The way that I'll remember SIGMETs and AirMets is A is first in the alphabet, which means that's just it's brand new. So I'll just pretend like the S is bigger than the A, and it's more severe than the A. Do you know what I mean?
Yeah.
That's what I'm gonna go towards.
So if you go up here to forecasts,
okay,
come down here to prog charts. This will bring up these different charts here. You can kind of start scrolling down. You can kind of take a look. Like this is a surface prognostic chart here. You can go into it. So this will kind of show you your frontal boundaries and your high and low pressure areas. So that's a surface prog. I mean, once you start scrolling through here, you'll notice that it has a lot of the stuff you've been looking at. So come back in here, you can even click on, different radar charts. It'll just kind of bring up a lot of the same stuff, but you can scroll down. A lot of times it'll have stuff below it. If you want to look at regional radar, then you can click on that and it'll zoom in and show you something, more regional there.
Or kind of like sectional charts.
Yeah, in a way, it just does a zoomed in look at the radar. So you've got wind and temperature charts. So this is the winds aloft at 30,000 feet. You can come down here and you can change this around, go up to 39,000 feet. You can play around with a lot of these settings here. You can also bring up winds aloft. If you want to bring them up just in the text format, you can click on an area and it'll actually bring up all the winds aloft for that region.
Okay. Yeah,
So
so just so I can read these correctly, those these winds of left charts. Let's see. So I know that 9900 means calm winds. So if it says like 2319 plus 07, near the 6000 or below that.
yeah,
So that's basically telling me the heading of 230 at 19 knots, and only if it's above 24,000 feet, you would want to change the temperature to a negative, right?
yeah.
Okay.
So that means, yeah,
That's
wind coming from 230, 19 knots, temperature is plus 7 degrees Celsius. Yeah, once you get up here, anything above 24,000 is always going to be negative. So it doesn't need to tell you that here. You just know that it's negative.
Hmm.
So if you see how it always says it right here though too. Temperatures negative above 24,000.
okay. I didn't see that.
But yeah, so that is how you read that. Now, how do you read this one right here?
That one, I believe. Can you zoom in a little bit?
Yeah.
Yeah.
Hold on just a second.
That one.
At least I thought I could. Let's see.
Okay. I think I know how to go with that one. So I know that you kind of apply the same rule, like above 24,000, you change to negative, and that's when you do the standard temperature is 15 degrees Celsius, and then you basically every 1,000 feet you go up, you minus 2 degrees, and that's how you figure out your your ISA and your ISA deviation. Am I correct?
Yeah, sorry, I was trying to figure out how to zoom there for a second. So, so go back to the top there on that one, Matt.
Okay, so
Still trying to figure out how to get this to zoom in. Does it look pretty small on your guys' side?
it says 741352, right?
Yeah.
Okay, so I know that if it's above 24,000 feet, like the other rule, then the 52 becomes a negative, and then if that's a 74, anything above 360, you minus 50 you minus 50, and you get your new number. So that would be like 74 minus 765,432. So 74 minus 50 is 24. So you would read
Where are
it
you
as
getting minus 50?
Isn't it like anything above 36? You have to minus 50.
Yeah, so here's the thing. So if you so the first thing that you see here, right? You see it as a 7, okay? So if you see any so just think about it this way. So you know that a complete circle is 360 degrees, right? So it's impossible to have wind coming out of a direction any higher than 360 is basically what Matt's saying. So if you see, so like when you first look at this, if you know that the first 2 digits are the wind direction, then you look at it and you're like 74. Well, because you know that you always need to add a 0 to these, right? So wind can't come from 740 degrees, right? So it should automatically be like, oh, that can't be possible. So anytime you see wind with either a 5, a 6, a 7, or an 8 that starts with a 5, 6, 7, or an 8, okay? When you
Not a 4?
No, not a 4, because that one would be 0 anyway. So like if you
Okay.
you can't minus 50 from that is what I'm saying. So, but if you see 5, if you see a winds aloft, the first digit, if it starts with a 5, 6, 7, or an 8, then the very first thing you do is you minus 50 from that number. So in this case, it's 74. You minus 50 from it, and it becomes 24. Okay? And that 24 means that the wind is coming out of 240. So now it makes sense, right? Wind coming from 240. The reason that you're doing that, though, is the middle number. So this only happens when the middle number, which is our speed, okay? So the first two that we were looking at was the 74. Okay, that's the wind direction. The next is the speed, which is the middle two numbers. So now what it's telling us here, and the reason that this happens is because the wind speed is technically over 100 nautical miles per hour. So, but since they can't put an extra digit in there, there's only 2 digits allotted for the speed. What it means is anytime you see a 5, 6, 7, or an 8 on the wind direction, what it's saying is you want to minus 50 from that number, and then you want to add a 1 in front of the second set of numbers. So what it's telling us is that the wind is coming from 240, and then we add a 1 at 113 knots. So that's the rule, and then the temperature is the same. It's just negative 52, like we already do anyway on any of them over 24,000. So just remember, if you see a 5, 6, 7, or an 8 at the beginning of the winds aloft reading, you want to minus 50 from that number, and then you want to add a 1 to the speed. And so basically, like I said, that just means that the winds aloft, the speed is over 100 knots, and that's basically how they work around it. Otherwise, you would think that the wind is only 13 knots.
Who in the world decided that was a good idea to do it this way?
Well, the problem is that they only have 6 digits to be able to do it. And so once you get used to it, though, you'll think the opposite. You'll think, yeah, actually that's was a pretty good idea. Because you should automatically be tipped off.
I trust you.
Well, the thing
Yeah.
is it tips you off. You know that you can't have a wind direction of 740. You know that you can't have one from 500 or 600 or 700 or 800. So, that's that should be the first thing. So you take those first 2 digits and you minus 50, and then you just add a 1 to the second ones, or just a 1 in front of the second ones. You should automatically just trigger in your head, okay, that means the wind speed's over 100 knots. That's why they're doing that. Otherwise, they just would have left it alone. It would be 24, 13, 52, which just would have meant wind from 240 at 13 knots at negative 52 degrees. So
is there ever going to be a time in any of these winds aloft that it's going to say like 44, 13, 52, or are they never going to display 4?
no.
Do you know what I mean?
No, because that first digit will always either be it'll always either be a 0, a 1, a 2, or a 3. Because the winds alofts only go, and like I said, unless the wind speed's over 100 knots, and then you'll see a 5, 6, 7, or an 8. See, the thing is if it's a 0, then they'll just have a 0. So if it was 0.4, you would just know that it's 40 degrees. Okay? Because you're always putting a 0 on the end of that number, because they're only giving you to every 10th on these directions.
Yeah, I got it. Okay, I was just wondering if there's ever going to be a time where they would put a 4, but I guess 4s don't exist in this situation.
Yeah, because if you take a 4 and you minus 50, you're got a negative number. Yeah. That just doesn't even make sense at all.
Yeah.
So.
Okay.
So yeah, you got to have at least the 5. So now the 5 obviously kind of works the same. Like sometimes I've seen it both ways, where they'll either just have a 0 at the beginning or they'll have a 5. But either way, that's the same reading though. So so any other questions on Winds Aloft readings?
No.
So yeah, you've got a lot of your charts in here that you can go into. See, there's convective segments. There's no current ones. You have the TCF page right in here. So yeah, everything that you guys looked at is in here. It's just you got to play around with it a little bit, but everything is in here. Aviationweather.gov. You should be able to find any chart that you guys have been looking at that Garrett's brought up.
All right.
Okay, so what other questions do you guys have about weather? You guys just want to jump straight into the review?
Yeah, that sounds good to me.
Okay. All right. Let's turn off the screen here for a second. So no last.
Did you say that there's going to be? So did you say there's going to be two tests this week?
Well, there will be a weather quiz, and that's probably all you're going to see this week is just the weather quiz.
Okay.
Okay. All right. So no other last questions on anything about the videos or any of the reading information you guys went over? Clear as mud?
No, sir. Yep.
Okay. All right. So I'm going to turn off the old screen here for just a second.
Kind of nervous about tomorrow because tomorrow's the day I have to take that ADX again.
Oh, yeah. Well, make sure you're studied up for it. Okay, so I'm going to start asking questions here, okay? So with this, as we go through this review, just if you have any specific questions on the question, then, go ahead and chime in and we can talk about it. But as far as I'm not sure how many of you guys are write down the questions or whatever, but if you're writing them down and you get a little bit behind in keeping up with the questions, then I don't really like to have to keep going back to repeat questions from earlier. I would rather you just wait and then rewatch this part of the video and then write them down. So just to kind of keep everybody on the same page and just to be able to keep on track. I just think sometimes it'll get a little distracting if we're going back and forth between them. So hopefully we can get everybody's participation with this. Be able to get everybody answering. So let's talk first about, let's see. How often are METARs issued?
Every 4 hours.
METAR.
Once a day?
Nope. So we're talking about METARs.
Once every hour.
Correct. METARs are issued every hour,
Oh.
every 60 minutes. At least, okay, at least. So,
Oh yeah.
so on a,
Hourly schedule.
yeah, correct.
Sure.
A METAR is scheduled for every hour unless what happens? What would be a situation
get a
where we would get
spec-
more than one METAR within an hour?
Bessie.
You can get the species if there's a significant enough change that it can't wait for the next hour to be up.
Yeah, exactly. It just has to meet those rules, right? Okay. So regarding the METARs, okay, so you need to know how often they're issued, okay? That's every 60 minutes, so every hour. You would need to know why a specie METAR would be issued, okay? And you don't necessarily have to like go and dive into the exact rules behind every situation that a specie would be issued, but if when you get this question on the quiz, you need to be able to describe saying, a significant change in either wind direction, wind speed, wind gust, visibility, cloud, ceiling, any of those things. You need to be able to say a significant change in, and then list those things out: visibility, cloud cover, wind direction or speed. If you just said that alone, that you would get credit for that question, okay? A significant enough change that it can't wait until the next regularly scheduled METAR. So we've talked about basically two questions there. How often is a METAR issued? And then why would a specie METAR be issued? Okay. The next question is, what are the 5 required items? And this is regarding weather, okay? So I'm not talking about station identification or the time or the date. I don't care about any of these or any of those things, but I want to know what are the 5 weather requirements, okay, that have to be in a METAR. The 5 required items regarding the weather that have to be in a METAR.
You need wind direction, wind speed, like your visibility, like your ceiling, your temperature, and your dew point.
Okay.
I think.
And so
Did I get all of them?
Well, you named 4 of them, and we'll go over them again. But what's the last one you think?
Like the precipitation.
Not the precipitation.
You gotta know the
Say
time.
that.
Well, regarding the
the
weather.
weather-related things.
Weather related.
Wind direction, wind speed, visibility, like the sky condition. I'm not.
Okay. Yep. Now, yep.
I'm trying to think
one more.
of what they all would
Just
be.
one more.
Like
Anybody else?
the cloud amount.
So let me tell you the ones you've named. Okay. So
Damn, I don't know.
okay. So far she has said wind, and you don't have to separate that between wind speed and wind direction. Just wind. Okay. Just say
okay.
so. Just wind. Wind, visibility. Okay. Sky condition, which is, so you named that, you're talking about the clouds. So wind, visibility, sky condition, temperature, and dew point, which is one thing, okay? But that's one thing. Temperature and dew point is just one item. And what's the 5th thing? What comes right after the temperature and the dew point?
Altimeter.
Ceilings.
Altimeter. Altimeter setting. Yes. Okay. So Greg, going back to your ceilings, is covered in the sky condition portion. So wind, visibility, sky condition, temperature dew point, altimeter setting. Those are your 5 weather required items that have to be in a METAR. So I'm just giving you guys some time here in case you're writing them down, which I hope you are. Wind, visibility, sky condition, temperature dew point, altimeter setting. So if you're reading a METAR and you notice one of those missing, or if you call, a lot of times as dispatchers, we will call an airport's ASOS machine and we'll get the verbal weather over the phone. If any of those 5 items are missing, then the computer little voice over the phone will actually say, it'll go through each of those things. It'll say wind missing. It'll actually say that. Or visibility missing. Or whatever one's missing, it'll say missing right after it says it. So you'll know if you do it that way. If you're actually just reading a METAR, then you have to train your eye to know to look for it. But that actually happens a lot. Sometimes those little weather stations, ASOSs and AWOSs, they tend to malfunction quite a bit. And they have all of these different instrumentation on them. I'm not sure if, Sierra, you were there when we went and kind of did the St. George Airport tour there.
Yeah.
Remember when we went out by the weather station?
Yeah, it was creepy.
Yeah, so it had all that different stuff on it. It had like that,
Yep.
It's got tons of different little instruments on it. So all it takes is for one of those little instruments to malfunction, or, you get some dust on it, or if you get a bird that comes and lands on it and messes it up or something, it can send any of those little instruments, into a haywire and make them not work. So it happens.
Even dust, like out there in the desert.
Yeah, if it gets like all clogged up and makes it so that it can't, read visibility and stuff, yeah. But yeah, I mean, in a lot of airports, birds are the biggest problem. They'll come and they'll land right on the sensor, and all of a sudden, that airport, even though it's perfectly, 10 miles and clear, it'll suddenly show like quarter-mile visibility, or something like that. And then we've had people that we've had to call them and have to drive out there and like kind of shoo the birds away before. So I mean, you'll see a lot of like little weird things like that. But anyway, yeah, you got to have all of those 5 items in your METAR in order for it to be a valid METAR. Okay, good deal. So let's talk about TAFs. How often are TAFs issued?
4 times a day.
Okay, 4 times a day. So that would mean every how many hours?
0000 Zulu, 0600 Zulu, 1200 Zulu.
So I want to know
1800.
how many hours, and I don't want to know the times. I want to know
Oh,
how many hours.
6.
Every 6
every
hours.
6 hours.
Yep. Every 6 hours. Okay. That's the minimum requirement, right? That's the minimum. At least every 6 hours. Same thing that goes with the SPECI, like the METAR. You can get an amended TAF issued if the forecast changes significantly enough that it warrants issuing one sooner than the 6 hour part, that 6 hour time frame. Let's see here. Okay. So let's talk about ISA then. So what does the acronym ISA stand for?
International Standard Atmosphere.
Yep.
Standard atmosphere. I couldn't remember if it was like intermittent or international. Yeah, standard atmosphere.
Yeah, International Standard Atmosphere. Okay. So let's see here. So I could hear Yvonne there in the background starting to answer that one, but I'll give this one to you, Yvonne. What temperature and elevation does ISA represent?
15 degrees Celsius, and the altimeter reading at 29.2. Is that what you wanted?
Yeah, so 29.92.
Oh, 29.92, sorry.
Yeah, 29, but what elevation does that represent?
Sea level.
Sea level, correct. Yeah, so the big thing that you guys want to remember about ISA, okay, is that the two biggest things are that it's 15 degrees Celsius, like Yvonne was saying, and sea level, okay? You're going to use ISA a lot, especially once we get into the manual flight planning. So, yeah, really good. So, yeah, 15 degrees Celsius at sea level. That is
So it's
ISA.
so it's 0.01 per thou, isn't it? Or 0.1 per thou.
For the altimeter? Or
For the
Pressure.
for this conversion. So it's like 29.92. So it's 0.1 per thousand.
2 degrees Celsius.
Yeah, the one we use is the 2 degrees Celsius per 1,000 feet. So, but from like the altimeter standpoint, yeah, like 0.1. So like 29.82 would mean like 1,000 feet usually. Is that kind of what you're going for there, Greg?
Yeah, just 0.1 sticks out. Sometimes on questions they'll not give you enough information. You have to hack it out using 0.1. So.
Yeah, correct. Yeah. So, but the big thing that with ISA that for your guys' sake and for the flight planning that we're going to be doing is just remembering that ISA represents 15 degrees Celsius at mean sea level. And then the altimeter setting for the 15 degrees Celsius at sea level also would be 29.92. And then going back to that other thing, the 2 degrees per 1,000 feet, that is the lapse rate. Okay? So when you're talking about ISA, if conditions are representative of ISA, right? So 15 degrees Celsius at sea level, then every 1,000 feet that we go up in altitude, we expect a 2-degree drop Celsius in temperature. So if we're 15 degrees Celsius at sea level, meaning that if we went up to 1,000 feet, we would be at 13 degrees Celsius. If we go to 2,000 feet, we'd be at 11 degrees Celsius, and so on every 1,000 feet that you go up. That would be following ISA, okay? Now, we're going to get a lot more into that when we get into flight planning, and you're going to get a lot of practice with that. So other than just knowing the rules behind the lapse rate and what ISA is, that's really all you need to concern yourself with right now. Okay. So here's kind of more of a basic question. What is the primary basic cause of weather, of all weather on our planet?
I'm sorry, I had to think. What was that?
What is the primary basic cause of weather on our planet?
Oh,
Like the uneven heating and cooling of the Earth's surface?
Exactly. Yep. The uneven heating of the Earth's surface. That is literally what causes all of the weather that we get anywhere on the planet. It's the way that the sun moves around and heats up this area, cools down this area. Wind, because of that, wind will shift because wind likes to go from hot to cool. That causes everything. It causes the wind, it causes the clouds, it causes anything that you can name derives itself from the uneven heating of the Earth's surface. So that's what you want to have down as the answer to that question. The uneven heating of the Earth's surface. Okay. Let's go to Marisa on this next one. Can you name 3 different types of cloud formations?
Like cumulus, but it's like there. I don't know these 3.
So cumulus, that's one. And then you said cirrus, is that what you said?
Zera, cumulus. I might be getting.
Yeah. So yeah, there's lots of different clouds. So you just got to name 3. So yeah, we've got cirrus, altocirrus, cumulus, cumulonimbus. Yeah, anybody else want to throw some out there?
Lenticular clouds.
Yeah, lenticular.
What are those like really? Gosh dang it! Those very dark, thick, fat clouds. Or did we already say that?
The dark, thick clouds, you're saying? Those
Yeah,
are
it's like
like thunderstorm clouds?
yeah.
Those are cumulonimbus.
Okay.
So you can say cumulus, nimbus, or put those 2 together and you've got cumulonimbus. Yeah. Stratus, cirrus. But yeah, so you just need to be able to name 3 different types of cloud formations. So we already answered this, but what cloud type is generally associated with a thunderstorm?
Cumulonimbus.
Yep, cumulonimbus. Let's see here. So John or Evan, do you guys have audio that works on your guys' computers? Okay. So you can just type it in then, okay? Type it in. What are the 3 stages of a thunderstorm? Okay, so he's having a hard time remembering. Let's see. Evan, are you on there? Can you type or talk on yours? Not sure if he's on there or not. Jordan, how about you?
I can't remember for sure, but I was thinking it was the first stage was cumulus, then mature, then dissipating.
Correct. Yeah, that's good. Yep. So you can say cumulus or cumulating. Either of those two will work on the first stage, and then mature being the second stage, and dissipating is the third stage. Okay, good. Let's see here.
What would you say for the first one again?
Cumulus or cumulating?
Accumulating.
Cumulating or cumulus. That's basically just the stage where it's building up.
Gotcha, yeah. Getting fluffy.
Yep. Okay, let's see. Go with Greg here. So, Greg, can you name 3 different types of fog?
No, I don't remember.
Want to take any stabs?
I can't even. I just remembered how to identify it in the METAR, and that's it.
Okay. Anybody want to help him?
I remember radiation fog,
Mm-hmm.
and I remember. I know the other name for it is the upslope, or like the upslope fog, hill fog.
Upslope.
Those are the only two I remember off. Slope fog. Those are the only two I remember off the top of my head.
What about Eddie? It starts with the AD.
Advection.
Yeah, advection. Yeah, advection fog, radiation fog, upslope fog. What's that?
Is there steam fog?
Steam
Over
fog.
water.
Yep.
Ice.
Ice fog. Yeah, there's a lot of different types. So just need to be able to name 3 different types for the quiz. Okay. So now that you know a few of the different types of fogs, see if you can answer this question. What type of fog is associated with warm, moist air coming into contact with a cold surface? Warm, moist air
That's
coming in.
the advection, or is that the one that Matt just said? That's the one that starts with the A.
Advection fog?
Advection fog, yeah.
Yeah, warm. Yep. Warm, moist air coming into contact with a cold surface. Any questions on that one?
Sorry, did you say that was advection?
Advection.
Or
Yep.
advection?
ADVECTION.
Thank you.
Okay. So let's see. We'll give this one to Matt. Okay. So Matt, name 2 different types of ice that form on airplanes.
Name 2 different types of ice that form on airplanes.
Yep.
Name 2 different. Well, I know that I've had to de-ice a couple times within the past weeks. And 2 different types of. clear ice, and rime.
Yep, that works. Clear and rime, that would work. That would count as 2. Anybody else know another one?
Mixed.
Mixed, yep. Clear, rhyme, mixed, yeah. That's 3 there for you. So you just need to be able to name 2 for the quiz. Okay, let's see here. Okay, can anybody tell me what the purpose of a weather observer is?
You mean like the AO2 part?
No, no, not that. That's in a METAR.
Purpose of a weather observer?
Yeah. A weather
Observe
observer.
the weather.
Yeah.
Like the and forecast to
Yeah.
foresee, or like to let people know. I guess I don't know. Try and
Yeah.
inform, to track and inform for safety.
Yeah, so a weather observer is a person that basically works at an airport, and it's not necessarily their main function, but they are trained to be able to read the weather, okay? And what they do, technically for us, is in the event that the ASOS or the weather station there at the airport, let's say that the power goes out, or let's say that for whatever reason the ASOS or the AWOS weather station is not working, or it has an element missing from its reporting or something like that, the weather observer person that works at that airport is trained to be able to go out and take a weather observation and supplement the whatever's missing or whatever's malfunctioning from the weather report that the weather station provides us. Or let's say that there's complete power failure, and we need the entire weather reading, then the weather observer can go out and do all of that and give us an entire weather reading. So
Is that different from from the meteorologist that works at the airport? Like, is that a separate position, or is it the meteorologist for the airport that goes out and does that?
Well, so meteorologists, normally you're not going to find a meteorologist that works just at an airport. One will normally they normally work at the National Weather Service or somewhere but airports in general do not have meteorologists working at the airports. So typically what you're going to see is an airport will have a weather station, like an ASOS or an AWOS that gives us the weather information that we need. And sometimes you'll have some trained weather observers, and a lot of it depends on how big the airport is itself, but a lot of times you'll have some trained weather observers. And it's also important to note that air traffic control people, like if you have an air traffic control tower at an airport, those people are usually trained as weather observers as well. But there's a lot of airports that don't have air traffic control towers at all. Like St. George is a good example. There is no air traffic control tower in St. George. However, several of the people that work there at the airport that work for SkyWest specifically, and Matt, you should learn to see if you can learn who some of these people are and talk to them about what they had to go through maybe to get their weather observer training. But anyway, there's several people there that are trained as weather observers in case we need them. If the St. George ASOS, if there was, if it malfunctioned or power failure or anything like that. Because the thing is for us is, in order to be able to land and depart at an airport, we always have to have a current weather reading. Even though we can look outside and we can see that the sky is blue, that there's no clouds, and that the visibility is unlimited, that doesn't matter. We have to have an official weather report, or we are not authorized to land or take off. So if something happens to the ASOS and it's not reporting the weather, that means that we cannot operate in and out of that airport. So if we don't have a weather observer in place, then we're basically grounded as far as that airport is concerned. But if we do have a weather observer, we can just simply call the weather observer and say, hey, get out there and give us a weather report and call it into us. We can use that as long as the person is trained as a weather observer. So the best way to answer this question is, what is the purpose of a weather observer? The purpose is to supplement or augment the weather readings at an airport, and in the case of, power failure or a missing element from the actual weather station, if it's reporting something or not reporting something. So it's basically just to assist in those times when we need, something to. Hey, can you guys hear me?
Yeah.
Hey, sorry about that. Don't know what happened. My hotel internet connection went down for a second and then came back on. So sorry about that. Anyway, so yeah, the purpose of a weather observer is just to assist in giving us a weather report when the automatic weather reporting system is unavailable. That would be probably the best way you could answer that question. Okay, moving on. Can somebody name 4 different types of weather frontal systems?
Are you talking about like the hot fronts and cold fronts, like those lines on the charts?
Yeah. So can you name 4 different types?
Hot, cold, stationary, and occluded.
Yeah.
Or
So
is that, did I say that right? Occluded?
yeah. So the only one you want to change around there is instead of saying hot, it's a warm front.
Warm.
Yeah. So warm front, cold front, occluded front, stationary. We also have a trough. You could use that. You could use stationary, occluded. Yeah, I mean those are your most basic ones though. So I just need to be able to name 4 of them. Does anyone know what the term anticyclonic means?
No.
Anticyclonic is counterclockwise, right?
Yes.
Spins counterclockwise.
Yeah, exactly.
Okay.
So, well, sorry. What I should say is cyclonic means counterclockwise. Okay, so
Oh.
yeah, cyclonic means counterclockwise, so anticyclonic would mean clockwise. So if you remember, so like if you're in the northern hemisphere, what direction does a tornado spin?
Clockwise?
So in the northern hemisphere, a tornado would spin. So it's a tornado is a low pressure. Okay, so like a thunderstorm would also usually be a low pressure. So low pressure systems in the northern hemisphere spin counterclockwise. Okay, and so like a cyclone, which is basically like a tornado, you know, it's or like a hurricane is another example. A hurricane spins counterclockwise in the northern hemisphere. So if you ever watch it like on a radar map, you'll notice that the spin is always going to be counterclockwise on a hurricane or a tornado or any type of low pressure system in the northern hemisphere. But cyclone basically means counterclockwise spin. So anticyclonic would mean clockwise. So anyway, it's kind of just it's a term that they use in weather. Yeah. So a lot of times they'll say we have a cyclonic weather system moving in, which just basically means like a low pressure spinning counterclockwise. Or sometimes they'll use the term an anticyclonic weather system, which just basically means a high pressure. So in the northern hemisphere. So if you go into the southern hemisphere, all of that is flip-flopped. So let's see. So why do dispatchers avoid filing their airplanes into or around volcanic ash?
You broke up a little bit on my side.
So why do dispatchers avoid sending their planes into or around volcanic ash?
Won't it
Absolutely
suck up into the engines?
Just destroys your engines,
Yeah.
parts, everything.
Yeah. Yep. It's first of all, it's it's not visible. That's one of the big things. Is you can't. Well, it's visible if you're approaching it, obviously, but like at night you cannot see volcanic ash. Another thing is you can't see it on radar, but yeah, as you're flying through it, it's like little tiny particles of rock, and as it hits into the airplane, it can melt and adhere to the aircraft itself, like to the turbines on the engines. It can gum up the engine basically, and it'll change the shape and the aerodynamics of the airplane because it's hot and it's hitting the plane, and it'll stick to the plane, so it therefore changes the shape of the wing. It'll change the shape, like I was saying, of the fan blades to where they can't get any air suction into them. Were you guys able to watch that video on that British Airways flight that flew into volcanic ash?
Yeah, that was a what is it called when you get like a reaction from thunderstorms that is non-threatening, like that lightning, like that light show that they were having?
The St. Elmo's fire?
Oh, okay, yeah, that.
Yeah. So yeah, I mean there's a lot of reasons we named there, but yeah, basically volcanic ash is hazardous to an airplane, and it can change the shape of the wing, the engine inlets, the fan blades, and can obviously cause engine failure.
I heard or I think he told us about this one day that that Yellowstone National Park was having a volcano like all the dispatchers thought that Yellowstone was about to erupt.
Yeah, he was playing a joke on him, you mean?
Oh, okay, that was a joke. I thought it was real.
Yeah. Yep. Let's see here. Somebody want to name 3 adverse weather phenomenon that are associated with thunderstorms? Anybody?
Would lightning be one?
Lightning would definitely be one. So what else do we get with thunderstorms?
Hail.
Hail? That's a big one, for sure. Wind shear, John says.
Wind.
Yep. Microbursts. Yeah, a lot. Those are big ones. So you need to be able to name 3 for the quiz. Name 3 adverse weather phenomenon that are associated with a thunderstorm. Lightning, hail, wind shear, microbursts. Yeah.
All the bad stuff.
All the bad stuff that airplanes hate. So somebody describe 2 things that help a pilot detect that he might be flying into a microburst.
Weather radar.
That doesn't always help you detect it necessarily.
I feel like this is in the video.
Pitch of the aircraft.
So what specifically though? Like, so what would happen to the pitch if he was flying into a microburst?
If you're flying in initially, don't you pitch up?
So you're going to initially get an increase in headwind, right? So
you pitch up and your lift increases.
Yeah, it's going to kind of be, it gets a little confusing for a pilot because initially, as you guys have learned about the principles of flight, we always like to have like a headwind for an airplane is always going to help it perform better, usually. So it initially you're going to get a performance increase. So you're going to get the headwind. So you might notice a decrease in speed, however, because of a headwind. And you might also notice, that the aircraft wants to pitch up, kind of like Greg was saying. Then what would be the next thing that you might encounter as you continue flying into it?
Isn't it something to do with the throttle?
Well, I mean, kind of. I mean, we just talked about that a little bit, though, that you would see potentially a decrease in speed because of the increased headwind. But what would be the next thing? So the next big thing would be a downdraft. So as you fly into a microburst, you're going to have increased headwinds. You're going to have the aircraft may want to pitch up, and then as you enter into the microburst, you're going to have a sudden downdraft hitting the airplane. So it's going to be wanting to be sinking down. And as you're flying through it, suddenly that the wind is going to eventually switch to where it's going to be a tailwind, and it's going to want to be pushing you out of, you're going to get an increase in speed because it's going to be pushing you out of the microburst. So those are two of the big things as you're flying in. You'll notice an increase in the headwind, pitch up, downdraft, and then the aircraft obviously will pitch down, and then an increased tailwind as you're flying through the other side. So, but yeah, you need to be able to describe two things that help a pilot detect that he may be flying into a microburst. Okay, so let's talk about icing again here. So name two things that icing can cause to an airplane while it's in flight. What are two adverse effects from icing?
Like, I don't know if I'm going to use the right terminology. Like, it'll cause it to like stall on the wings. Am I saying that right? I can think of what it is. I can't think of the word.
It reduces aerodynamics, doesn't it?
It's going to cause it to slow down.
Yeah, the aerodynamics. Yeah, I mean, the icing, kind of like we were talking about with volcanic ash, it can change the aerodynamics of the wing because you have ice, forming up on the wing. So if you think about just the wing in general, the way it's shaped is perfect in order to create lift. It's got that perfect design to it to have air go over the top, and it's a smooth surface. So as you get ice onto it, it accumulates and it causes a rough surface. The air hits it, and it doesn't have that smooth pattern. So therefore, it interrupts the creation of lift going over the wing, which is going to make the airplane have to fly faster in order to create lift. So you have to. So when you're talking about the stall, it increases the stall speed. So the airplane therefore has to speed up in order to maintain the speed in order to not stall out. So yeah, that's one big thing.
Gotcha. Oh, are you still waiting on someone to give you an answer?
Well, yeah, if anybody else has anything else to throw into that.
Oh, okay. Um,
That
well, it obviously
reduces lift,
says
increases stall speed. That would be two things.
Significant drag.
Yeah, drag.
Drag, that was the word I was looking for.
Yeah. So just, yeah, I mean, that's three things there. So yeah, those are the big ones, though. Those are the ones you really want to remember. Okay, so let's see here. Let's see. So what weather characteristics and temperature indicate that icing conditions might be present?
Doesn't ice happen at 0 degrees Celsius? Isn't that freezing point for Celsius?
That is the freezing point, is 0 degrees Celsius, but it's not necessarily the temperature we use to indicate that icing conditions exist. I'm not sure if Garrett got into this or not. Maybe you guys can tell me if it sounds familiar or not, this question. But icing, basically you have to have two things in order for icing to be present, okay? There's two things that have to exist. One of them obviously is a temperature that's low enough for it to be cold enough to have ice. And then the second is that there has to be moisture present.
Moisture?
Yeah, moisture. So, because it could be negative 50 degrees, right? And if the skies are clear and there's no moisture present, then we're not going to have ice, regardless of how cold it is. And on the flip side,
Right.
if it's raining like crazy, but it's 90 degrees, same deal, right? I'm not going to have ice. So you got to have the mixture. So, but the temperature that we use is 10 degrees Celsius. So obviously, so it's above freezing, but the reason why we use 10 degrees Celsius is to kind of give us some leeway due to wind chill. So, because, obviously these planes are flying several hundred miles per hour. So as you're going through the wind, it might feel a lot colder than it really is. It might be 50 degrees, which is 10 degrees Celsius is 50 degrees Fahrenheit. So we take it all the way up to 50 degrees Fahrenheit with moisture present. So just a quick note, though, about moisture. What constitutes as moisture? Besides the obvious things, besides rain and snow.
Fog?
Fog. Yep, fog is moisture. Absolutely. What else?
Snow? Are we just naming all the
snow
types of water in the air?
Well, yeah.
Yeah.
And try to maybe search for the less obvious ones. But like fog would be one that people don't necessarily name a lot. Mist is another one. Mist, yeah. What about just clouds in general? Like, what if you're up in the air flying through a cloud?
Yeah.
Yeah. And that's a big one to remember is clouds are moisture. So if you have a temperature of 10 degrees Celsius or less with visible moisture present, so visible moisture is anything you can see. You can see fog, you can see rain, you can see snow, you can see clouds. So the term that we like to use is 10 degrees Celsius or less with visible moisture present. That is the definition of icing conditions. So to answer that question, that's pretty much exactly what you need, is what weather characteristics and temperature indicate icing conditions may be present. And that would just be a temperature of 10 degrees Celsius or less, and do not forget the or less part on that. A lot of people miss that, and then they get the question wrong because they simply just put 10 degrees Celsius and that's it. But it's 10 degrees Celsius or less, and visible moisture present. Everybody good on that one?
See.
Okay, we're just going to talk about wind real quick and then give you guys a little bit of a break. Everybody feel comfortable in their wind reports, being able to decode the wind?
Oh yeah.
Okay,
I think so. Yeah.
let's go with, I'm going to put one here in the comments. Let's see here. Okay, Evan, are you on here?
Yeah.
Okay. Oops, actually, let me fix that. Send this to everyone. Oops, I accidentally put it in there twice. But anyway, can you tell me decode that wind for us right there in the comment box?
I missed a couple days. I'm still catching up, so I actually I don't know how to do that yet.
Okay. Let's see. Marisa, how about you?
Temperature of 70. Wait, the knot. Oh no, knots is 72 knots. No, I'm getting confused. It's 95 knots. I just got the 250.
Okay, so the 250 is what?
That's our wind direction coming from the 150 degrees.
Okay.
And then I'm getting confused with the 72. I thought that was.
So the 72 is our wind speed.
Right. And I'm not sure what the E and the 95.
Okay, so does anybody want to help her out?
Yep. The G just means gusting, so 72 knots gusting to 95 knots.
Thanks.
No problem.
Okay, good, yeah. So wind 250 from 250, 72 knots gusting to 95 knots. Okay, so you need to be able to decode a wind report on this quiz. Okay, and you need to be able to know, by looking at that wind report, you need to be able to know and say what direction. If I were to give you that exact wind report, and then if I were to ask you what direction is the wind blowing?
Well, if it's 250, that means it's the wind is blowing to the east. Because if it's coming from 250, that means when you're landing, you're going against the wind, which means it's going towards the east.
Yeah. Good. Yeah. So that's one thing you guys need to remember. So if somebody gives you that wind report and they ask you what direction is the wind blowing, remember that that direction that's given to us in the wind report is telling us where the wind is coming from, like Matt was saying. So in order to get what direction the wind is blowing, you need to go the exact opposite of that direction, technically. So if the wind is coming from 250, that means it's coming out of the west, southwest a little bit. So if it were directly west, it would be coming from 270. But it's coming from 250, which is 20 degrees towards the south. So it's a little southwest wind. And if it were going directly east, it would be 090, blowing 090. So you add 20 onto that one, or sorry, if you minus 20 off of that one, you would. So it's basically blowing 070. So anyway, but yeah, if you were to say it's blowing east, northeast, somewhere up in there, that would also work. But just remember, if somebody asked you what, the idea here on this question is just for you to be able to identify what direction it's coming from and being able to flip that and tell me what direction it's blowing. And last question here is name 3 different types of surface visibility restrictions. So what type of weather causes surface visibility restrictions? This one should be pretty easy.
Fog.
Fog. What else?
Haze or dust?
Haze, dust. Yep, both of those work. Can snow cause a surface visibility restriction?
Yes.
Yes, it can. Can a cloud cause one?
Wouldn't a cloud on the ground be considered fog?
Yeah, pretty usually, but you can still get a cloud on the ground. I mean, it basically is the same thing, but yeah, clouds can do that. But a cloud counts. That's the reason I say is because you could list cloud and it could count. So.
Gotcha. Cloud.
So you named dust. Rain. Can rain be a surface visibility restriction?
Definitely.
Yeah. So pretty much anything weather-wise can cause a surface visibility restriction. So just need to be able to name 3 of them. So any issues with that from anybody?
No.
Okay. Good. Well, let's.
Will you run by me one more time what icing can cause? I got drag and then I got caught up on what we were talking about.
So it can reduce lift, increase drag. Reduce lift, increase drag. It can, increase the stall speed.
Increase stall. Okay, so I did have that. Right. I couldn't remember the word for it, but I knew what I was trying to say.
Yeah. So, yeah, those will work. So,
okay, cool.
All right. So, let's see. How long of a break do you guys want to take here? I know we haven't had one at all yet, so figure I'd give you guys a chance to, if you want to grab something to eat or whatever. But let's just say you guys want like 25, 30 minutes, or you guys tell me what works best for you guys.
Yeah, that sounds perfect.
Okay. Let's just plan on being back on at 5 to 8. So at
7:55?
Yeah.
Okay.
Yeah, 7:55. Does that work? Okay, we'll see you guys back on here in about 30 minutes. Okay, good deal. Well, you guys enjoy your little break there?
Yeah. Is it bad if so out of all 1,100 questions, I only missed 245 total, so that's around a B range, I think, or that's around an 80% range. So those are the ones I'm going to be studying like crazy tonight.
So what did you do? Take them all at the same time or something?
Well, no, I put them all down by each category, and then went through each category another 2 times to make sure that I got 100% on it before moving on, and then I just basically added up all the ones I couldn't get, and now I'm on the marked questions.
Okay. Yeah.
Are you going tomorrow?
Yeah.
Nice.
But hopefully, if I fail tomorrow, which I really hope doesn't happen, then I'll take it with you next week.
Yeah, I'm taking my Wednesday morning next week.
Or hopefully sooner than that I can, but yeah.
I should have taken it already. I was ready to take it before class, but I got cold feet and put it off.
Well, just make sure you're not losing any of the material, if you know what I mean. If it's what can easily happen
right.
when you change your thought process and start doing all this dispatch stuff. Kind of.
Yeah, I took off. I blocked out this weekend, and I took Monday and Tuesday off work for to just cram all the information, go over everything again, and then I'm going to take it Wednesday morning.
Cool.
So I got 4 straight days.
Cool. Well, good deal. Well, you guys ready to move on to the next topic here?
Sure.
Human factors? Is that what we're doing?
Yep, human factors. So we're going to talk a lot about the human element of dispatching. So we're going to talk kind of about some of the downsides and the positive sides and a few of the different philosophies, I guess, about human factors. So just turn on my screen here. Okay, so this is kind of the beginning of the practical dispatch application part of the course. So this week we're just really going to be talking about human factors and the decision making and situation awareness and things like that kind of evolve around the human factor subject. So last week, with kind of watching some of those aviation accident videos, even though they were mostly weather related, you were able to see that a lot of those accidents all have human elements to them, whether they be human error, human input, and, decision making. It played a role in every single one of those accidents. And so it's kind of a good leeway into this subject for us to be talking about this week. So we're going to take a look at a few different things and kind of start talking a lot about the steps and the things that we do as humans that are going to potentially impede us as dispatchers, and things that can cause us to make errors and have unsafe situations, and also the things that we need to do as dispatchers to be able to help the pilots that are flying the planes and our crews, and also the people even just around us in dispatch, to be able to make good decisions. So for a long time in the aviation world, there's been kind of this I don't know if you call it like a sentiment or there's been this, I guess, a philosophy over the years. So it's not like this necessarily anymore, but as aviation evolved over the years, there was this sense of you have your crew, right? You'd have your captain, you'd have your first officer, and back then, and when going back into the 40s and 50s, a lot of those crews, it was more than just a captain and a first officer. There was a flight engineer, flight navigator. So sometimes you'd have 3 and 4 people in the cockpit, all assisting in, for the flying of the airplane in some way or another. So over the years, obviously, those positions have evolved to where now we just have really 2 pilot cockpits, right? The flight navigator position specifically, and the flight navigator / flight engineer position itself has kind of evolved into the dispatcher, where obviously the dispatcher is not in the plane physically, but those positions were kind of replaced by the dispatcher position, and obviously taken out of the airplane and kind of put on the ground to where that they can assist with the flight planning, the fuel planning, the navigating, and all of those things that they used to be in the cockpit for. So that's kind of as you we're going to look at some more videos and some other things here throughout this week. And so kind of just keep that in mind. That the dispatcher now is kind of your modern day flight engineer / flight navigator. So, but anyway, as aviation kind of evolved, a lot of times the captain was always kind of looked at as like he's the main guy, he's the one who knows everything. You don't question him. You don't undermine his authority. You don't, if whatever he says is what goes, essentially, and you don't speak up, you don't voice your opinion, you don't voice disapproval. It was kind of just one of those authoritarian type situations where the captain was the one who was going to make the decisions. He was the one that needed to do, if there was ever a situation going on, he's the one that needed to critically think and solve the problem on his own, and a lot of times there was this fear from either the first officer or other members of the crew, even from flight attendants, and not that they thought that the captain was just a complete jerk or anything, but there was just kind of this ingrained sense that you don't question the captain, if that makes sense. It was just kind of one of those things that you just didn't do. And so if ever there was an emergency situation or any sort of a complex situation going on, it was kind of just an understood thing that unless you're the captain, you just keep your mouth shut. Okay, does anybody see that the why or if there would be potential issues with that type of an environment?
So are you basically saying because of that, why could that cause discomfort? And I'm not sure how to word it. Never mind.
A good example of that was I brought it up a few days ago, but Korean Air, especially in the culture of the Korean culture, is to your elders or your superior or the person in command, the co-pilot or the first officer attempted to bring something up and he was squashed several times and they flew right into a mountain, shooting an approach, killed everybody on the aircraft, and since then drove a lot of kind of leadership changes on the flight deck. So
yeah, absolutely. In fact, that it's been a really big emphasis in the United States and for the carriers that fly, that are United States-based carriers. There's been this big attempt to have a culture shift away from this, this environment to where people don't feel like they can have input or say, or they just simply don't dare to. However, a lot of the international carriers still have these problems. They still have that culture to where, the captain, if the captain's doing something or if he's flying the plane, you don't say anything, you don't do anything, you just if something looks out of place, you just let it be. You don't mention it because you don't question whatever the captain's doing. In fact, I'm sure all of you guys remember the Asiana crash that just happened just a couple of years ago in San Francisco.
No.
The Boeing 777. Nobody remembers that? It was just, you're talking like 3-4 years ago.
Are you talking about when they shot an approach and crashed it?
Hit into the seawall?
Yeah.
I mean, nobody died. If you guys remember for those, if anybody has this kind of fresh on their mind, but yeah, they basically came in too low and they ended up hitting into the seawall, which is, if you have to understand how the San Francisco airport is, but it basically, the runways they pretty much extend out into the bay, out into the water. And so as you're approaching in, you're basically flying over water all the way until literally the pavement of the runway begins. In fact, the approach lights are even in the water. So, but as you're approaching the runway, right from where the pavement starts, there's this, maybe a 5-foot little seawall that's right there to help kind of protect the runway itself. But anyway, the plane came in too low and it smacked into that seawall, and it causes the plane to completely do like a 180, and it flips over onto its side and skids along, and then all of a sudden it bursts into flames, and everybody was actually able to get out of the plane, and luckily there was one fatality, but it had nothing to do with the accident itself. There was one fatality, and it was a woman who had gotten out of the plane, and I'm not, nobody's obviously sure what exactly happened, but as the fire trucks approached the wreckage, there was flames everywhere. They started shooting the foam spray that they use to put out airplane fires. Anyway, that foam began to build up on the ground, and apparently she was laying down. Maybe she had a leg injury or something, I'm not sure, but she ended up getting covered up with this foam, and the fire truck couldn't see her and actually ran her over. That was how the one person died. It actually just, completely ironic that a person just survived a plane crash just to die by getting hit by the fire truck. Kind of weird circumstances, obviously, but bad luck either way. So anyway, the reason I'm bringing
I got a question about that, though.
Okay.
So was it a clear night, or sorry, was it a clear day when that happened?
Yeah.
Okay, so what kind of confuses me is how did the pilot not notice that he was too low shooting the approach by not looking at the
we're about to talk about all that part, so just keep here for a minute. So so basically the circumstances that caused the crash was that the pilot, that they were bringing in the plane too low on this approach, and there was, I think, 3 or 4 other pilots in the cockpit at the same time. A couple of them were doing training, and then you had just your regular first officer plus the captain. This is one of those long transoceanic flights. It'd come all the way from Korea, probably a 12 to 14 hour flight all the way over to San Francisco. And as they're so it has multiple crews on board because they have to take shifts in flying the plane in order to remain legal as far as their the amount of time they can fly. So anyway, so they were setting up for the approach, and they put all pretty much everything they're doing is on autopilot for the most part, and they're so a lot of times it's because they're so reliant upon instruments and things like that in the cockpit. Sometimes when things aren't right, they don't notice because They're just used to things working the way that they're supposed to. But if you have, if you put in wrong inputs, or if you, miss something by a degree or this or that, I mean, you can have a totally different outcome for what the plane, how the plane actually flies, dependent upon what you're telling it to do, And so yeah, you would think, going to your question about did they not notice and things like that, it's, I'm sure that if, normally if you were trying to notice that, yeah, you probably would, but a lot of times it's hard to even tell, especially when you're bringing in an airplane that size, of, exactly if you're too low or too high. But anyway, long story short, I don't want to spend all day on this one, but long story short is there's a culture with those, it was, Korean pilots as well that were flying this plane, and it's just a culture of, none of them wanted to say anything, but as they were coming in on approach, several of them noticed that it appeared that the plane was coming in too low. And furthermore, one of them noticed that the plane seemed to be flying too slow. Like it was so too low and too slow. Those are two very bad things for an airplane. If you're low and slow, is kind of what they're calling it, or how you'll hear to it, referred to as. But you don't want to be low and slow, because you can, you'll end up not having enough power, and you're going to end up coming in below where you need to be. And that's exactly what happened in this situation. But nobody wanted to bring it up. Several of them noticed what was going on, but not one of them actually wanted to sound off and actually say something and bring it to the attention, because it's just not what you do. He's the captain. He was flying the plane. He's the authority figure, and nobody wanted to say anything. And sure enough, the plane was too low, and by the time the captain actually realized it, it was too late. He tried to power up, but it wasn't in time. He was already, only a couple hundred feet from the runway, and he tried to power up those engines to get some more speed, but at that point it was too late to correct the situation, and the back of the airplane slams into that seawall, which was just in front of the end of the runway, and and then it caused the plane to, like I said, it's an amazing thing that there was only one fatality, and that one fatality had, literally nothing to do with the actual crash itself. But what could have happened, obviously, could have been a lot worse. But the moral of the story here is that the whole thing shouldn't have happened, because 2 or 3 other people in the cockpit at the time noticed that there was something that it wasn't coming in at the correct speed or height. And had somebody simply chimed in and said, hey, you need to speed up, or you need to gain some altitude, or, you're off the glide slope, even several things that were there that could have been done to completely avoid the entire crash itself. And it's, I bring that up because it's a recent one that happened, and it's one that has kind of that culture that we talk about, that people don't want to say anything, if they're not the boss. I mean, and this is not just in aviation. This is obviously in a lot of different work environments, and I'm sure that all of you guys can probably think of stuff that happens in your daily lives, of situations where you don't want to say something. So there's been this big shift in aviation to make it be, to make everyone feel like equals, and to make everyone's, opinion and their voices be heard. Like if there's even if you go around, even outside of the cockpit, in aviation in general, there's this slogan out there that, you probably see it if you're at an airport. You see it a lot of times if you're in the security lines at an airport. There's little posters that say, if you see something, say something. Right? Has anybody ever seen that?
Yeah.
So anyway, that's kind of, it's a term they use a lot in aviation, but yeah, it's kind of this thing to where they're trying to get people like, if you see something that doesn't look right, speak up, because people's lives, in the aviation world especially, people's lives are literally at stake. So you got to say something. Don't be shy. Don't be timid. Don't be, don't, if you feel like there's going to be backbiting or backlash against you for saying something, you just need to get rid of that whole sentiment completely. And I think, at least for the United States-based airlines, they're doing a pretty good job of it. But over the years, they're trying to take out this human element out of flying. I mean, there's part of the human element that you absolutely have to have, but there's also parts of it to where we rely too much even on the human element, and we rely too much on the human to do the job that, just by being a human yourself, you have the tendencies to be able to forget, to do something wrong. It's not always automatic. It's not computerized. And so if you look at any aviation accident, there's always a human factor that ends up contributing to the outcome of the crash, or even to be the reason why a wreck happened. But going back over the years of all of these crashes that we've had since aviation literally began, at first it was kind of, aviation was a new thing. And, it was kind of, for the first several, 10, 20, 30 years, crashes were kind of looked at as like, oh, well, we don't know a lot about aviation. So, it's kind of one of those things where they looked at aviation crashes as being like one of those growing pains, a price that we had to pay in order to learn about it. So for the first, like I say, 30 or 40 years of aviation, it was one of those things like where they were looked at as just an expense that almost had to be gained in order for us to learn more about planes and how they fly and why they crash. But obviously, after that keeps happening for enough time, there becomes a shift to, okay, well, for the first, the first so many crashes had a lot to do with more of just mechanical things on the airplane. Oh, well, the wing didn't work right, or this aileron didn't function right, or the engines gave out, And so for the first 30 or 40 years of aviation, the emphasis was on making the systems in the aircraft better, making it so that the mechanical things on the plane didn't fail, because that's what was causing most of the accidents. It was perfecting navigation. Planes were just, they're just cruising along at cruise altitude, and all of a sudden they run into the side of a mountain. Well, it didn't have anything to do. Everything was being done right, but navigation was so poor back then that they didn't have the technology to be able to avoid it. So for the first 30 to 50 years of aviation, the emphasis was on perfecting systems and perfecting, making all of those systems better to where we're not just having these crashes, all the time, and people aren't losing their lives because of the systems on the aircraft, and engines aren't failing and things like that, or catching on fire. And then the shift kind of went more to, so it went from kind of like the mechanical factor, and then it kind of shifted more to like an individual human factor, okay? So after a while, we kind of started getting rid of, you started seeing less and less major accidents that had anything to do with mechanical failure, and they started realizing that all of the crashes they were now having had human error element in all of them. And then for the next, 30 or so years, that's what they were seeing. They were seeing, and we can go back and we can look at all these, but you started seeing all of these crashes that were all human error related. And so the shift, because the mechanical systems had kind of started getting so much better that, those crashes were almost eliminated. And then you just simply were just seeing crashes. You were seeing a lot less crashes overall because they got rid of those mechanical related ones mostly, but you still had all of the human error ones in there. And like I said, even though the total amount of lost lives and overall aviation accidents was significantly down, every single one still had a human factor element in it. So anyway, they started to shift their focus towards human factors and they spent years and years and years now working on that. And then as they started to kind of work through those, and a lot of those emphasis that came out of those are kind of some of the stuff I've been talking about, like the culture shift of if you're not the captain, you're not allowed to speak up, and just getting through a lot of the things of where anywhere we can remove the potential for human error, they've tried to remove it out of there. One really good example is pilots always used to they used to be taught to memorize all of their checklists. So pilots have a ton of checklists that they go through. They have, from the moment they get on the plane, like their pre-flight checklist, their pre-taxi checklist, a pre-engine start or an engine startup checklist, takeoff checklist, after takeoff checklist, climb checklist, all of these, pre-landing, like you can name all of these checklists. If they had an emergency, there was a checklist, but pilots were always taught to memorize these checklists and that they needed to have them verbatim by memory so that they could just do things, so that they had it down, that they felt like if a pilot could memorize these things, that it was going to help decrease some of these human error related accidents. And it did, and it did. But after a while, they started to realize that maybe, that they started to see like little errors and like crashes that would be caused simply because a pilot was trying to go off of memory instead of actually using a checklist aid. So it's kind of a weird thing, but they then shifted away from the checklist model. They still have these checklists, but they're taught to not memorize them now. Or, not that they're taught to not memorize them. They still like them to try and have them in memory, obviously, but they're taught now, and what now is pretty much a mandatory thing, is that they actually have to physically read the checklist in lieu of memorizing it. And that's simply because they want to remove the human element out of a human thinking that he has the checklist memorized. So, and people can do a really good job at memorizing things. However, if you forget one item and you don't know that you forgot it, that can have catastrophic consequences. So now they're teaching pilots that they need to pull out these checklists and go through them line by line, even though they've done it 100 times, 1,000 times. You always take the checklist out and you go line by line and you physically read it and physically check that item, whatever needs to be done, in lieu of doing it by memory. And that removes that human factor element out of the checklist. And if you have an emergency, you take out that checklist and you do what it says. You don't try to go by memory because, humans are great and everything, but there's always potential for error if you're trying to do things by memory. So now there's this big shift away from that. But that's just one idea, one example of kind of what we're trying to get at. Another thing that they've focused a lot on is training for decision making, and there's these they call it crew resource management, and then there's another factor that we'll talk about later called dispatch resource management that we're going to talk a lot about actually. So I've got there's two videos here that I want you guys to watch, and I'm going to post these links here. If I can get this 1 second here. Okay, so the first one here. Okay. So this first one is 7 minutes long. So I'm going to have everybody, if you guys just want to click on that link, I want you guys to watch this video first, and then we're going to discuss it here. So I'll give you about 10 minutes or so. Watch through it, and let's see, it's 10:26, so we'll jump back on at 10:36 here, and you guys just start watching this, and then we're going to discuss this here in about 10 minutes. So just go ahead and click on that link and start watching this one. All right, everybody get a chance to see that?
Yeah, they were all over the place.
Yeah, so what were some of your guys' takeaways from that little old school video we just watched?
Trust.
Trust. What else? What were some of the issues there? Like what?
They explained away all the safety concerns really quickly. And
Yeah. So what was the problem from the beginning? Like what caused the problem that they were in?
They didn't follow procedure. They got caught monologuing, and first he didn't transfer the weather, supposedly, and then it's kind of like one decision begets, another bad decision, and it just exponentially grows.
Yeah, exactly. It's kind of like a couple of things that all happened, a couple of people forgetting their duties that all kind of led to the whole problem, right? And so even after they figured out their error, what did they they came up with potential solutions, right? And so what ultimately kind of, that you guys see in there, what was the driver of their decision making towards the end of this?
the punishments they'd get if they diverted, like the pilot wouldn't get to do his training. The guy wouldn't get his leave.
Exactly, because if they diverted in this situation, they were going to have to divert to the Cocos Island, right? And the only way you can divert to Cocos Island is by declaring an emergency. And that was going to look poorly on all of them. The captain, the first officer who was waiting to go to, do his upgrade and go to his, upgrade class. And I mean, it was going to look bad on all of them because it was the captain's responsibility that they all, that, he's the one that left the cockpit and left them in charge. So no matter what happens, it reflects bad on him. And then, yeah, everyone kind of had their reasons for not wanting to draw attention to themselves, which ultimately those personal drives led them to make the decision to just continue on, right? And just to continue on, and put themselves in greater danger. So that, that's part of how the culture has been over the years. It is things like that, and that's kind of what the new emphasis is. Obviously this video is old, but there's a big emphasis now to try to get rid of that type of mentality and those behaviors. It still exists, and it still causes issues and puts flights into scenarios that they don't otherwise want to be in or shouldn't ever want to be in if people would just stay on top of their duties and not get complacent. That's the biggest thing, is complacency, and complacency is a natural human element, right? And so it's impossible to completely get rid of it, but they're trying to put things in place to where it mitigates it, right? To mitigate complacency, because it's always going to exist. As long as you have humans flying airplanes, you're going to have potential for human errors. Complacency is always going to be one of them. Making a decision based off of personal gain or how embarrassed you're going to feel if you have to, declare an emergency and divert like they were in this situation. So yeah, I mean, it's little things like that to where rational decision making can completely go out the window. People would rather continue on with the fear of what would happen if they had to do the safe thing and declare an emergency and divert. They're more afraid of that than what would happen if they continued on without the fuel needed for an alternate and got all the way to their destination and weren't able to land and ran out of fuel and crashed the plane. So that's human error for you, though. Human error is sometimes not capable of rationally thinking in a critical situation. And so that's, like I said, that's something that they're trying to get rid of. So this next video I'm going to have you guys watch.
While you're pulling that up, I ran into talking with a 20-plus year captain with Delta that is now in crew resource management training. And he summed it up like this. He said, the challenge is in my early years that we had a number of people in the cockpit. It was fairly simple instrumentation, and it was an art. You became really good at it from a lot of years of experience. And that couldn't quickly and easily be replaced by someone coming online and jumping in the cockpit. So there was a very much a pecking order as to when you spoke up. And then as the equipment evolved and is evolving at breakneck speed, that breaks down very quickly. So now someone next to you can be just as informed, if not more so informed, given the equipment he has. And so he said it's just 100% about keeping up with process management, because NTSB blames pilot error in most accidents, but it's not just that. Something happens external to them, and then it's how they process that, how they link together with the equipment they have available, that's just been very difficult for them to stay on top of and match equipment versus human and how they interact with each other. So he said it's a challenge.
Yeah, exactly. And that's one thing too, is that there definitely is no replacement for experience, right? Just being in certain situations and having a tenured captain that has had thousands of hours of flying, that has seen almost any situation you could think of. There's a lot of times there's just simply no replacement for that. There's no amount of training that can duplicate that. They're getting better at it, obviously, the training and things like that. But at the end of the day, there's simply things that cannot replace actual experience. And that's that's how that sentiment was, kind of like Greg was saying. It's like, you don't have those things that don't exist to replace those factors. However, and one thing that, they kind of look at nowadays is like, okay, if you have a brand new first officer that is fresh out of training, just as green as you can get, fresh out of training, just went through, learned everything, gets into the cockpit and sees something that goes against what he was just literally trained. I mean, there's an element to this as well. It's like, would you rather have, depending on the situation, would you rather have the guy that just came right out of training, or the guy that has all the experience that maybe has let some things slide or been complacent over the years? Because both of them exist. That's the problem, is, whether a human intentionally does it or not. They call this philosophy, they call it practical drift. I'm not sure if anyone has ever heard of that term, but practical drift is where, you take a person that has been taught how to do something right, and, they're fresh out of training, or even in the case of a captain that gets retrained. I mean, they all go through recurrent training every single year where they go and they focus on all sorts of new things. But the longer you go without having had recurrent training or having, gone through a refresher on certain things, the more you tend to drift away from the actual procedure. And as time goes on, you will drift more and more and more the longer you go without, renewing your training or renewing how it's supposed to be done. It's just natural. That's just normal human behavior element, is to have this practical drift away from the actual way something is supposed to be done. And so they're trying to develop new strategies and training and things like that to get away from this. But it's safe to say that a brand new person right out of training would have the least amount of this practical drift. However, how do you compare that to the captain sitting across from him that's been flying for 35 years, that has all the experience? And at the end of the day, it's not there is no replacement for either one of those things, and that's the thing. It's that it's the shift in this and the thinking behind all of this is that it all needs to be looked at as a team environment. There might be something that the guy fresh out of training knows, or maybe he sees something that because the guy across from him, it's been 35 years since he went through ground school training, that he just simply doesn't see or catch. It's okay for that first officer to pipe in and say something, right? That's how it should be. There is never, it's that the culture is being changed and shifted to where they want to let everyone know that it's okay, that you should always say something, and that nobody needs to be offended. A tenured captain doesn't need to be offended by a brand new greeny pilot coming out of training, calling him out on something that he, and it's not even that he's calling him out. It's just the ego. The one thing about pilots is there is a lot of ego from being a pilot, and so there's a certain personality that goes with being them. And then the other part of this too is, how does the dispatcher play into all of this? A lot of the really old captains do not like involving dispatchers in on any decision, but same thing with how the crew resource management has gone. They're also developing these things to where there's certain things that the dispatcher is going to have a lot more experience than the pilot. The dispatchers, they plan and dispatch up to 50 flights a day sometimes, and so dispatchers have a totally different angle on all of this stuff. Dispatchers will see a lot more emergencies just simply due to the quantity of flights that they deal with, where a pilot pairing might only have a couple of flights in one day. When a dispatcher he could dispatch 400 flights in a week. There's no way you're going to fly 400 flights in a week. So just simply due to the numbers alone, dispatchers are going to see a lot more circumstances and events and weather types and situations to where they're going to know how to be more useful to pilots, just because they've seen stuff. They see stuff a lot more. They're not physically in the plane flying, but they know what to do in situations that the pilot might not know what to do. And so they're trying to also teach the pilots to rely on the dispatcher, get his input. A dispatcher is a crew member. Literally, dispatchers are crew members. And as you guys have talked about operational control throughout this class, dispatchers have 50% of the operational control. They have more operational control than the first officer. Not to, take anything away from the first officer, but the captain and the dispatcher are the only two people that have operational control over a flight. And both of them have to agree and come to agreements on decision making in order for a flight to successfully operate. So keep that in mind too throughout this week as we talk more about human factor elements and things. But want to hurry and have you guys. This next one is 20 minutes. It's equally as old as the other one. However, this one is a little bit different on the outcome. But I want you to be thinking about these crew resource management things that we've been talking about, and be thinking about kind of this conversation that we've been having about the culture change. And this next one's kind of older, but it was put out kind of at the beginning of this attempt at changing the culture in the cockpit as to how it should really work. So here's the link. So go ahead and click on it. It is 20 minutes. So we'll jump back on in 20 minutes from now. So let's see. So 8:50. So let's just plan on 9:10. Just getting back on here. So go ahead and watch that, and we'll talk here in a minute.
about 4 of those positions are all instruments and computerized systems now, so I think it shifts a lot of that load. Well, I don't think it does. It shifts a lot of load onto 2 people.
It does. It does for sure. I mean, a lot of those things have been simplified. And then obviously a lot of that too now has been, shifted to dispatchers as well, So a lot of those duties, the fuel burn, the navigational side, the altitudes and things like that are more along the dispatcher's roles now. But yeah, there are a lot of the other stuff though, yeah, has been shifted to the 2-man crew. So it definitely is a lot different. So yeah, it hopefully kind of those 2 videos kind of helped you see kind of where things were and hopefully the direction that things are going. They, like I said, there's been a huge emphasis on making it a lot more like as a team effort, decision making involving, you've got all of these people that are around you that have a lot of knowledge, and the idea is use it. Use what you have at your disposal as a dispatcher. As you're sitting there, if you have situations come up that you don't know the answer to, the idea, even from a dispatcher's perspective, and like I was telling you guys that you'll learn. We're going to talk about dispatch resource management, just like they've been talking about crew resource management, but it's the same idea. As a dispatcher, you have so many other people that are around you. If you have questions on something, if something looks unsafe, if you have a flight that is going into conditions that you're not familiar with, you've got all of these people around you, yet so many people, they feel timid and shy and they don't want to say anything, or they don't want to alert their crew to something because they feel like, just for whatever human type sentiment feelings they have that, keep them from being safer or keep them from being more knowledgeable or using resources that are at their disposal, right? The person next to you, the person across from you, there's a lot of people in that room that have a lot of experience. And the best way for especially a new dispatcher to learn and soak it all in is to tap those resources that are all around you. One thing that, for me personally, I'm an aviation geek, I call myself. So, doing this job and working in this industry, for me, it's like I'm not working at all because I enjoy it so much. It's if I didn't get paid to do it, I would probably do it as a hobby anyway, And so it's kind of one of those things, and the thing is, a lot of people that get into this industry it's that same situation. You have to kind of have a great liking for aviation in order to get into it, like this, in order to want to be a dispatcher. I mean, that's at least my feeling. But I think part of that helps people also be better at what they do. If you have an interest in this, you're always going to be better at it. If it's something more than just a job, you're going to be better at it. If you're doing it just for a paycheck, you're probably not going to do a great job, honestly. So, but that's the same situation with anybody else in the room, typically. Not to say that there aren't people that just come in and clock out and don't care about a thing otherwise. There are those, but the majority of the people that are around you are in similar situations and have similar interests and also have a ton of expertise and knowledge. Everybody has something that they can teach somebody else, whether it's the newest person or the oldest person, with the most experience, or whether it's the most tenured pilot or the rookie pilot right out of ground school. It's the idea there is that, that rookie pilot may have had something, he has to have 1,500 hours of flying even to get to being a rookie pilot at an airline. So he's got a lot of flying under his belt, and there still may be things that he has seen that the tenured 40-year captain has not seen, just depending on the situation. Obviously it's more likely that the captain's going to have more experience and most things, but you just never know. If the circumstances are right, the idea is to bring everybody's resources to the table. Nobody is, the sum of the parts or the whole, is greater than the sum. So if everyone heard that term before, I probably didn't say it right, but the whole is greater than the sum of the parts. I think that's how you say it. Anyway, but yeah, so we're gonna. There was another thing that I wanted to get to today that it doesn't look like we're gonna have time to get to. It's about another aviation accident. We'll try and get into it a little bit tomorrow, but if you want to get a preview of it, there is. If you get into, I'm going to turn on my screen here, but if you get into today's folder, week 6, day 1, you'll see that there are several things in here, as well as the outline that has those clips from today. There's an advisory circular in here that talks about operational control. I definitely want you guys to get in and read that, even if we need to, cut some time off of tomorrow's class or whatever. But if you have time between now and tomorrow's class to get into this advisory circular, it talks about operational control, and it actually talks about the reason the dispatchers have 50-50 operational control. But anything in here that is pertinent that I want you to read through is actually in yellow highlighted. So even if you just go through and just look at the yellow highlighted areas, you'll get a lot of information. There's a PowerPoint in here. This flight we're definitely going to talk about tomorrow because there was a lot of interesting things that came out of this particular crash. It was the Alaska Air Flight 261 crash back in, it was in 2000 is when it happened. But there was a lot of things that came out of that crash, even from a dispatcher's perspective that affected dispatchers as well. So, but there's some audio that goes with that. So we'll probably look at that more in class. So you don't have to look at that. There's a PowerPoint in here as well that we're going to use for tomorrow. But if between now and then, if you have time to go through this advisory circular, that's kind of some outside of class reading that I wanted you guys to be able to look at. And the rest of this stuff we'll address in class tomorrow, this the PowerPoints and then this Alaska Air crash. So
Adam.
Yeah.
You mind if I say something about the crew resource management real quick?
Yeah, go for it.
So, it's kind of interesting that, as Adam was talking about, the changes that aviation is going through, trying to be more inclusive of, everybody's different backgrounds. And one thing that I find interesting is every time I jump seat, the captain will brief me on, the safety procedures in the cockpit or whatever. But then the thing that he always asks me, whatever captain it is he's always, or the captains have always said, if you see anything out of the normal, please bring it up so that we can address it. They know that I'm not a pilot for an airline. They know that I don't have the experience, but they still want you to know that if there is a problem, that sometimes you might see something that they don't. Sometimes you might see an aircraft that is, that they haven't picked up or they don't see, or, just something like that. They want to know. They want to address each and every situation and make sure that there's no more that macho type. I'm the captain. Just be quiet and sit there. It's interesting to see the changes in aviation lately. Because like Adam, I've been very, very into aviation my entire life. So
it's been pretty interesting to see how much it's evolved just in the last even 10 years. So yeah.
Yeah, I mean, I've had situations where I've been in the jump seat, and same thing as Garrett was saying. They almost, the culture now is to where even as a jump seater, they will say, 3 sets of eyes are better than 2. And if you see something, you say something. Kind of, like I was saying earlier, that little saying is everywhere in aviation now, whether it be in the security lines or if you're sitting in the cockpit. So everyone seems to be using it. I'm here at the FAA Academy, and I see it everywhere posted in the buildings around here, even in the cafeteria. So, and it's not just, it relates to everything, I mean, but yeah, I mean, the captain, that culture now should be, if you're seeing anything other than a culture of inclusivity and team, type decision making, then you should honestly be speaking up, and saying, because that it really doesn't fly anymore. Those types of behaviors and those types of, those macho, personas, they don't. It's just not acceptable anymore. And those people, they still exist, unfortunately, and they're still out there. But they're becoming a lot fewer, from what I can see. But I've had situations where I've been in the jump seat, and I remember on one particular night we were flying into St. George, and it's not that it's same thing. It's like Garrett was saying. It's like I don't have, I don't know. I mean, I think that I could maybe fly the plane because I've seen, how it's done so much, but that's just me being me thinking that I could, when I probably couldn't. But obviously, I'm not a pilot in there, and I don't, necessarily, know how to do anything that they're doing. But you never know when a situation is going to come up that they don't know something that you do know something about. And usually that's going to be dispatch related, but you can have stuff that happens in the cockpit, in certain situations where your input just from sitting there in the jump seat is extremely valuable. And one night, flying home back to St. George, we were flying in, and I may have already told this story. Stop me if I have, but we were flying in to St. George, and as soon as they tuned into the CTAF radio, which is just the common traffic radio frequency, since St. George doesn't have an air traffic control tower, they have to just get onto a common frequency and announce their position. Anyway, as soon as we tuned into it, we just heard all this chatter about, there was all of this like it just all of these different voices talking basically on the frequency, and ultimately what was going on is that there was a military exercise going on at the St. George Airport, which the crew had no idea that it was going on, but it was just really weird because as soon as they tuned in, all they could hear is like this like a base commander type guy on the ground that was sending out all of these commands for different airplanes and helicopters that were in the area, running kind of a mock like mission scenario, but they were doing it all on the common traffic advisory frequency for St. George, and they were at the St. George Airport, but they were, as soon as our flight was coming in, and it was late at night, it was like 11 p.m., and they had to literally wait for there to be a break in all of the chatter to where they could actually chime in and say, hey, this is SkyWest 7393, and we're 20 miles out, on a final for runway 19 for St. George. And as soon as they said that, there was like I said, the little commander guy that was on the one, doing the most of the talking gets on there and says, oh, that last transmission, please repeat, getting on there like, who was that just called out? Anyway, so gets back on, he repeats himself, SkyWest 7393 coming in, 20-mile final, runway 19, landing in St. George. And then the guy gets back on the radio and says, "No, this airport is closed for a military exercise. You are not cleared to land." And it was just the weirdest thing. The pilots, like, what? They were just looking at me like, what is going on? Just the craziest thing. And the guy's telling them they can't land. They didn't, they weren't planned for an alternate or anything else. They didn't have any extra fuel. And this really doesn't have a ton to do with dispatch, but it's just simply to the fact that while I was at work earlier that day, I had heard somebody telling me about this military exercise that was supposed to be going on. And anyway, so we ended up having to go out and hold over Zion National Park for like 10 or 15 minutes while they cleared people out of the way to let us get in. But I kind of chimed in. I said, "Oh yeah, hey, I know what's going on." And I told them, they're doing this Marine exercise. They flew in all of these choppers and aircraft from down near San Diego. They flew them up for the night to do this mission exercise to simulate desert Afghanistan type conditions. And so, like I said, it didn't have a lot to do with dispatch, but it at least kind of gave them some information, that I knew what was going on, and I kind of felt like, no, what should I tell them or not? But, there was no NOTAMs or anything else saying that the airport was closed, and it took them a while to convince the guy to actually let him land, but, he ended up letting him get in there. But it was a weird scenario, but, whether it be dispatch related or not, you never know when you might have some information that the crew might be able to, have as useful information that they don't otherwise know. So speak up, say something, if you're in that situation. Every little bit that anyone can offer is going to be valuable. So anyway, I don't have anything else. So if anybody has any questions or wants or needs or anything else you can think of, chime in. Otherwise, we'll all chat tomorrow.
Sounds good.
Okay, guys. Well, have a good night. Enjoy your evening. And read that advisory circular if you can. And we'll talk to you tomorrow at 5:30.
All right. See you tomorrow.
Thanks, guys.
See you guys.
Bye.